Okay, class, welcome to lesson 1.2, ratios of angles. So we're taking a look at our trigonometric angles, sine, cosine, and tangent, and we're going to be rotating them about 360 degrees. So today we will be looking at finding the ratios of angles rotated about the origin, kind of like what we introduced yesterday, but we're going to take it a step further. For this, we will need to remember which sides are the opposite and adjacent. We will also need to calculate or find the length of what's called the hypotenuse. Okay? A line from the origin to its endpoint is the hypotenuse. So take a look on this diagram here, guys. That's going to be our H. Okay? It has a length, so we can calculate it using the points of the point coordinates. Okay? Example, determine the length of the hypotenuse and determine the primary trig ratios. Well, first of all, the key part here is realizing that we've got an ordered pair of 8 and 6. Remember, guys, that this is a 90-degree or a right triangle. So I could extend that just to a triangle and not even worry about the rotational grid part itself. So what I know is this is my angle. And just think, the x-coordinate deals with your horizontal move. So that means that that side length of the triangle has to be 8, whereas the y-coordinate deals with your vertical movement, which is your 6. So in order to find the hypotenuse, or the longest side length in our right triangle, we can remember Pythagorean theorem. So you know h squared equals 8 squared plus 6 squared. Okay, simplifying that through, h squared equals 100. And remember, to get h by itself, you have to take the square root of both sides. So h equals 10 units. Okay, so in that case, we would have that h equals 10. Okay, then it says to determine the primary trig ratios. Okay, so just remember the sine theta equals opposite over hypotenuse. Okay, so using our values from this angle, our opposite side is what, folks? Our opposite side is 6. And our hypotenuse is 10. Let's put that in lowest terms, which would equal 3/5. So that's one of the three primary trig ratios. Let's do cosine. So cos theta equals the adjacent side over the hypotenuse. Okay, the adjacent side is 8 over the hypotenuse, which is 10, and that simplifies to 4/5. Whereas our tangent theta, sorry, I should have left more room here, guys, is our opposite over our adjacent, which equals the opposite side, which is 6, over our adjacent side, which is 8. And again, we reduce it to lowest terms, so 3/4. So again, guys, we used one single point to calculate the radius or the height, sorry, the hypotenuse in this case. We will then down below here transfer it to radius. So I was jumping the gun there a bit, guys, but the radius is the same as your hypotenuse, so I don't want to confuse you there. We use Pythagorean theorem to find the missing piece of the puzzle because, again, we had two sides, and if you have two sides of a right triangle, you can find the third. So we found the hypotenuse, and then we stated the three primary trig ratios. All right, now we're going to extend that a little further, and hopefully you can remember your circle equation from last year, or maybe grade 10. So it says, if we place the end point on the edge of a circle centered at the origin 0, 0, we can use the circle formula to solve for the hypotenuse, which is now called the radius. So again, this does look like Pythagorean theorem. It's based on the same thing. Okay, so instead of h squared equals x squared plus y squared, we're just going to say that the hypotenuse is the radius because it's the longest side, and we take the square root of both sides. So the radius equals the square root of both two sides, the sum of both two sides squared. All right, all under the square root sign. Now, if you take a look at this diagram, folks, I would write this in your notes or make sure you reference it. I think it's in your key concepts page for today's lesson. Okay, part of it is anyway. Okay, so again, we're dealing with the same type of triangle here, and we've got point X and Y. All right, Based on our primary trig ratios, for example, we'll start with sine theta. Sine theta is the opposite over the hypotenuse. Looking at our diagram here, guys, the opposite side is y over the hypotenuse, which we're now going to call r. Okay, these are things you're going to want to remember. Okay, now let's go in order. Cosine is the adjacent side over the hypotenuse side. Again, you can use SOHCAHTOA to remember this too, or visually quickly draw this. Okay, and if we transfer that over into our circle diagram here, again, the adjacent side is x, and your hypotenuse is radius. And lastly, ladies and gentlemen, your tangent ratio, which is your opposite over your adjacent, gives you the tangent theta of y over x. And in industry, ladies and gentlemen, this is the most widely used. Okay, so if you're ever into construction or building a ramp or any type of roofing, you're going to be using the tangent ratio a lot to help you do some calculations. All right, let's take a look at some other examples on the next page. All right. Taking a look here, a primary trig ratio can be given along with a quadrant, because remember the quadrant will help us determine if it's positive or negative, or tells us where the terminal arm lies. Okay? Determine the other two primary trig ratios. So let's take a quick look here. We've got sine theta equals 8 over 10. Tells us it's in quadrant 1. Okay? So when I go to draw that, ladies and gentlemen, just remember sine theta is the opposite over the hypotenuse. So in this case, we're not given the adjacent side. So what do we know? We know that we have 10 for my hypotenuse, okay? And we know that we are given 8 as the opposite side. So in this case, what do we still need to find? Is basically the adjacent side. So we don't know the adjacent side, but we can use Pythagorean theorem to find that. Okay? All right. Any questions with that? So if you're not sure what letter to use, let's flip back for a second, folks. You flip back and say, hey, what letter do we need to find? We need to find x, right? So, because we still need to find this adjacent part here. So let's go back and do that. So we're going to find x. In this case, we're going to say x squared equals the hypotenuse squared subtract the other side that we're given squared. Okay, so doing that, you've got 100 subtract 64, which is 36. Okay, and don't forget to get x by itself, you take the square root of that. So x, in fact, equals 6. Now that we know x equals 6, now we have all three parts of our triangle. So now we can list the other two primary trig ratios. So we already have sine. Let's do the cos one. So cos theta equals the adjacent over the hypotenuse. And again, the adjacent in this case is 6 over 10, put into lowest terms, which would be 3 over 5. Okay, everybody okay with that one? Let's now find the other primary trig ratio, which is the tangent theta. Tangent is the opposite over adjacent. Okay, what values do we have for that? Okay, we're going to have the opposite side, which is 8, over the adjacent side, which is 6. Reduce that to 4 over 3. And again, what that represents is that the opposite side is 4/3 times the size of the adjacent side. Or if you're comparing these, if you simplify 8 as a ratio of 6, it's going to be 4 over 3. Okay, even though my diagram doesn't look like 8's bigger than 6, that doesn't matter to me as long as you understand that that represents a ratio of the side lengths. All right, let's try this last example, folks. All right, cosine of cos theta equals negative 5 over 13. It's in quadrant 2. Just remember our CAST rule, C-A-S-T. That makes sense that this is going to be negative because we are in quadrant 2. Just step back here for a second. Quadrant 1, all of them are positive, so we didn't have to deal with that. Okay? So what we need to do is to make sure that when we do quadrant 2, it's somehow going to be here, right? So theta's here. We got to figure out our values. So again, cosine theta equals the adjacent over the hypotenuse. And so when you think about the adjacent side, which is x here, okay, let me just change color. X, if you notice we're on in quadrant 2, x is negative. So when you take a look at setting this up as your diagram, guys, this is actually -5 value. Okay, and we also have the hypotenuse, which is 13. So what do we need to find in this case, guy, is the y component. Okay, and again, we have a 90-degree triangle here, so we're going to use Pythagorean theorem to help us get that. So y squared equals 13 squared subtract -5 squared. Now, -5 squared is going to disappear, guys. Okay, so when you get that, it's 169 subtract 25, which is 144. And don't forget, when you get y by itself, you take the square root of that. So y in this case equals 12. So now we have all three parts of our triangle, which means 12 fits here, -5 fits here, and 13 fits there. And then we can list our other two primary trig ratios. Okay, so what we can do, I apologize, let's just make some room here. Okay, so what do we need to do? Sine theta equals the opposite over the hypotenuse. So sine theta in this case is the opposite side, which is 12 over the hypotenuse, which is 13. That's in lowest terms already. And our last one, since we've got cos already, we'll do tan theta. Tan theta equals the opposite over the adjacent. Okay, our opposite value is 12. And our adjacent is -5. You've got to be careful here, folks. Never leave a fraction with the negative as a denominator. So you either move it out front or up top. Okay, so again, you would lose a little error for that. You don't leave it as a denominator. You move it out front, okay, or up top. All right. So hopefully that's a good understanding, guys, of taking a look at angles from 0 to 360. Remember, the key is use Pythagorean theorem to find the other side length of your triangle. Okay, give the homework a try here, guys. Page 5 and 6, numbers 1 ABC, 2 AB, 3 AB, 4 CD, and 5 ABCD. And have a great day, guys.